All right, today's study of basic radicals. A radical expression is an expression that contains one or more radicals. The radical sign, and that's actually what you're going to put on this line here, is the word radical. Sign. When we read it as the square root. So this example here would be called the square root of b. And the number that's underneath the radical is called the radicand. Radicand. And let's see. Think about what number times itself is equal to b. Kind of like you may have seen before in the past, and I'm going to try to scribble it over here, but where you would have the square root of 16 is equal to 4. 4 times 4 equals 16. So what number times itself would give you b, or in this case, the square root of b. So let me see if I can move it. There we go. Every positive number has two square roots, the principal square root and its opposite. I want to see if I can group these things together so that it won't move when I move. Okay, that's not working either. So I'm just going to push it off to the side for right now until I learn how to get better with it. So the principal square root for any number a and a non-negative number b. The square root of a number squared is just that number. Think of the square root and the square kind of as inverse operations, where if I addition, the opposite is subtraction. With multiplication, the opposite or the inverse would be division. So with square roots, the inverse would be squaring a number. So in this case, when you see a squared, the square root of a squared, it's just going to be a. That's it. And try to put a lowercase a in there. Just like that. So that's going to be I don't see what's happening here. All right. Get better in a moment. So this should just be a, not that. I want to see if I can undo that last a. There we go. Whoops. Move it back up. All right. So it's just going to be an a. And b squared, the square root of b squared would just be b. So the square root button is actually about 5 buttons down on the left hand side of your calculator, and it's going to be in blue, so that means you're going to have to press the second button in order to find the square root of a number. So square root of 49, 7 times 7 is 49, so the square root of 49 is just 7. The square root of 7 squared is 7, because those are inverse operations. The square root of 2.1 squared is just 2.1. And the square root of 0 is just that, 0. So the next main idea that we want to focus on is multiplying radicals. So let's move along. Let's see. There we go. All right. We can fill in the blanks to complete the property, then use it to find each product. So for any non-negative number, a and b, the square root of a times the square root of b is going to be equal to the square root of a times b. We just put it both underneath the radical. So right here on your next example, it says the square root of 2 times the square root of 8. That is going to be the square root of 2 times 8. Which happens to be the square root of 16, because 2 times 8 is 16. And 16 is another perfect, 16 is the perfect square. So your answer in this case is just going to be 4. Okay? And the square root of 3 times the square root of 7. If you want to try it yourself, go ahead and hit pause. But the square root of 3 times the square root of 7 is going to be the same as 3 times 7. So 3 times 7 simplified is 21. So in this case, because there are no perfect squares that I can pull from 21, your answer is just going to be the square root of 21. And that's it. All right. Let's move on. All right, so now we want to talk about how to simplify individual radicals. And I hope you take a moment at this time to look at the video on the radical party, because it goes into great details on what it is that you're looking for. We're actually looking for pairs. So according to Apex, the steps are to factor out any perfect squares. So that's any number that times itself would, you can take the square root of. Give me just a second here. So we're looking for perfect squares. Whoops, that looks imperfect. Let me see if I can write it over. Go back. How about I type it? Boom. All right, let's see. I don't know what's going on here. Okay. That's not what I want either. Let's see. Perfect. Done. Okay. So you're going to factor out any perfect squares from the radicand, and then you're going to split the radical into a product. So we're looking for what two numbers multiply of two radicals. So we're looking for the product. That's what goes on this next line here of the two radicals. And then we're going to simplify it as best as we can. So if I follow that rule here with example 45, the square root of 45. These are moving around. So I'm going to just push them off to the side because I don't need them anymore. So, for example, the square root of 45. The perfect square 9 is in there. So we have 9 times 5. So let's see, make it a little, went crooked. So the square root of 9 times 5, that was our first step to look for perfect squares. And then we want to split the radical. So we'll have the square root of 9 times the square root of 5, and we know that the square root of 9 is just 3. So our answer here is going to be 3 square root 5. And a lot of times students have struggled in the past with knowing if they did it right. So what you can do, grab your calculator, put in the square root of 45. The square root of 45 is equal to 6.71. And then you can also check to see if you did this right. Then when you put in 3 square root 5, you should get that same 6.71 or 6.7082. I don't know if how many you want to go behind, but 6.71. So that makes me happy because that just shows that we did it right. And that looks like a crazy happy face, but that's okay. Sometimes you got to get crazy with your joy. Boom, boom, boom. There we go. All right, so that's how we're going to simplify radicals, and that's going to come in handy a little bit later in our practice. So what we want to talk about next is, let's move this along. All right, in old state, you can use the quotient property of radicals to simplify radical expressions. So since you see the word quotient, I hope your first thought was division, because that's what we're about to do. So it says for any non-negative number a and positive number b, the square root of a divided by the square root of b is actually equal to the square root of a over b. All right. So let's put it into practice, because I know it looks a little weird until we can practice with some numbers. So what you have here is the square root of 30 divided by the square root of 6. And don't be fooled by fractions. Fractions are just your friends. And so we're going to do it like that, just like we have on our example, which is here. So we'll do the square root of 30 over 6, which 30 divided by 6 is 5. So that would leave me with the square root of 5. Since the square root of 5 cannot be broken down, and we can leave our answer in radical form, boom, that's it. The square root of 5, and you're done. Okay. If you want to pause for a second while you try the next one, but I'm going to keep going. So the square root of 48 divided by the square root of 3. You have the square root of 48 over 3. And 3 divides evenly into 48. So the square root of 16 is going to be, 16 is the radicand underneath the radical. And 16 is a perfect square. So, 4 is a perfect square that equals 16. So therefore your answer is going to be 4. All right. Now, keeping it moving. How to simplify the square root of a fraction fractions are your friends. So the steps are to split the radical into a quotient. I know these words are not working out very well for me, but that's okay. We're going to get better with time. Quotient. Quotient. Boom. All right, let's put it there. Of 2 radicals, and then we're going to simplify the numerator. And if you simplify the numerator, it's not fair unless you simplify the denominator. denominator. Boom. Just like that. So, for example, we have the square root of 10 over 9. So we're just going to do what we just did a minute ago, except we're going to work a little bit backwards. So instead of starting, I moved it. Instead of starting here and then going here, we are given this and told to go that way. All right, so we're just going to rewrite the square root of 10 over 9 as 2 separate, split the radicals. We're going to write it as 2 separate square roots. So here we go. Let's see. So the square root of 10 over the square root of 9. There you go. And the square root of 10, 2 times 5 is not a perfect square. So we're just going to leave that as the square root of 10. And down at the bottom, we're going to put a 3. Why is there a 3 there? I hope you know. Because the square root of 9 is 3. Bam, 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 bam. And that's your answer right there, ma'am. Okie dokie. So we're going to keep it going with the last one of our main ideas. So it says to simplify some radical expressions, you need to use all of the properties of radicals. Yes. So that means we're going to have to simplify. We might have to find products, whatever it takes to simplify these. Those didn't move right. So we're just going to push them off to the side and ignore them. So simplify each expression. Now, you have the square root of 3 over 8 times the square root of 5 over 6. Guess what we're going to do? Rewrite it and put it all underneath the radical. So we're going to have 3 over 8 times 5 over 6. And that little dot right there is for times. I don't know. So that's going to simplify to the square root of 15 over, I can't think right now, over 42. All right. And so that can be broken down. You know what? I did something backwards. I'm going to keep going and just admit that I was totally wrong right here. I don't know what's going on. I guess because it's Friday. Let me see if I can erase this. Might let me, might not. Who knows? I'm embarrassed. I don't know what's going on right here. Let's see if that's, it's making it worse. I want it to be better. It won't take it away. I got to learn how to take it away. Scribble, 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 scribble. That's why you do math in pencil. I wish this thing had a pencil where I could erase it. But that's okay. Here's what I did. When I did it by the notes, I went ahead and simplified a little bit before. By the way, 8 times 6 is 48, not 42. But anyway, 3 times 5 in the numerator. And then I did 8 times 3 times 2. Well, where did 3 times 2 come from? 6. So I was able to cross those out and kind of give myself a shortcut. Because I was awake when I did the notes. But I'm not awake right now. We got to give me some sleep. So the square root of 5. The square root of 5 over 8 times 2 is 16. And since 16 has a perfect square hidden in there, I'm going to put the square root of 5 up at the top. And down at the bottom, I hope you don't mind this shortcut, I'm just going to put a 4. Because 4 times 4 is 16. And that's it. You're pretty much done with that one. Okay? And our last problem before... This is really... Okay, let's get all of that out the way. There we go. All right, our last problem is 15... The square root of 15 over 7 times 21 over 20. So what I did was I went ahead and rewrote everything as the square root of 15 times 21 over 7 times 20. Now, what I did was I know that 5 and 15 and 20 are multiples of 5. So I went ahead and took the square root of 3 times 5. Where 3 times 5 come from? 15. And then I even broke down 21 to 3 times 7. Put all of that over 7. Didn't change that at all. And then I know 20 can be broken down to 5 times 4. I don't know what's up with this pen now. But that's 3 times 5 times 3 times 7 in the numerator and 7 times 5 times 4 in the denominator. So at this point, I know that 7 divided by 7 is 1, so that's gone. I know that 5 divided by 5 is 1, so that's gone. So what that leaves me with in the numerator is the square root. I can use this as the line of 3 times 3, which is 9, over 4. But knowing what I know, 3 times 3, that's a pair. I'm going to go ahead on and pull that square root out and have 3 over, and I know the square root of 4 is 2. 3 over 2, and that's going to be your final answer. Now on the next couple minutes, I'm going to just do a little bit of practice ones that I saw in the lesson. Okay.